Hello everyone, I hope you all are doing well. So, in the previous session, I had covered the Capgemini technical interview questions on CE domain. So, today I'm here with the KPIT interview process. So, again, a few of my colleagues gave this interview and I could able to collect the data from them. Let's see what are all the questions they have asked, and these questions will help you in future to face the technical interviews. So answer for these questions I have already covered in the CAE interview question basic tutorials, which I had covered in the past as well as in upcoming sessions as well. So kindly refer them. Okay. So I'll be taking you through the short glimpse of it. So the first question, as I said, the introduce about yourself. So I had explained how to just uh, create your particular answer for this question. So I had framed it in the previous session on caption interview questions. So please refer that. Okay. So next question, what are the steps and considerations we take to carry out the static analysis? So explain about this static analysis in depth. Remember, don't try to tell about the software which you know. Just try to explain the same concept using the software which they are looking for. Okay, so this KPIT is like dealing with the Abaqus and Hypermesh. So try to take that particular tool into account and try to explain this concept in that particular tool. Okay, so our initial steps: defining the boundary condition, creating the constraints, okay, defining the boundary conditions as well, applying the material, creating the material, okay, and then fixing the particular phase, okay, and then you need to create your answer in such a way that they should get impressed. Like there are some things like pre-processing stage, processing stage, post-processing stage. So like that, try to create the answer. Okay. Let's say if it comes to the pre-processing stage, what exactly is happening? So what exactly you want to do? So if you're creating the model inside the Abaqus, so try to explain it how you're going to create it, or if you're going to import it, so tell the formats which you're going to take it into account. So once you import it, what is the next step? Okay, so like that, try to explain each and everything. Well, so once I explain these things, the next question that had thrown on us is, what is the equation behind this static analysis? So I need to tell about that, no? Partial differential equation, the equation of motions. From that, you can just take it up, that is uh, stiffness matrix into displacement is equal to force. Okay, only explain that scenario. If you want, you can take through each and everything, so that with the added advantage that they will think that you know more about this, all the equations and all. So if you want, you can just explain in a better manner. So next thing, while dealing with the stress and displacement review, so they had asked about this. So you're considering stress results, right? So I told about the one versus stress. So why only one versus? Why can't we take something else? Simple question, right? For the ductile materials, so it is one versus is preferable in industry, so we take it. So I answered it. Didn't they don't want that kind of answer, so technically fine. So for this, you try to explain about the failure theories for ductile materials. Okay, distortion theory. Okay, that is known as same thing. One versus theory itself for brittle materials, it is Rankine theory. Coulomb's theory, Coulomb's Moore theory, modified Coulomb's Moore theory. So there are so many things behind it. For this question, so I'll just give you the glimpse. So why we consider the one versus? We know the stresses, right? Different types of stress, the tensile stress and the shear stress, maximum principal stress as well, right? Later on it will come. So the ductile materials will fail under what? The strain, right? Due to strain energy, due to the shear stress, they will fail, isn't it? So This one versus the distortion theory takes the shear failure into account, and it will try to formulate the stresses. So when it comes to ductile, it will take the maximum principal stress due to the tension. Okay, it will fail at the tension. So there we can just tell that the Rankine theory, and then explain about the Rankine theory. And if they ask about the one masses, try to dig up more about the failure theories and answer this question. Okay, what are the nonlinear analysis? So the simplest question ever. It's quite simple, frequency based, time based, frequency domain, what and all the things comes. But don't try to explain everything. Okay, if you know about that, let's say model analysis, okay, fine, harmonic, fine. Then if you go again in depth in different analysis, okay, they'll definitely catch you up and they will ask the questions on the same thing. So let's say if you say only model analysis, that's all well and good. So they will ask the next question. So what is model analysis? And explain about this. So the same question I got it there. So what are the time domain non-linear analysis? So try to explain that is implicit and explicit. What are the, so they have already directly asked. So if it is time domain, implicit and explicit. What are the implicit analysis? What are the explicit analysis? The implicit analysis comes under quasi-static. Even this frequency based also comes under the quasi-static. Okay. Explicit, explain why it is explicit. Implicit, explain why it is implicit. Okay. So there are things you need to just check and answer the same thing. If you want the answer, please refer my previous tutorials on the same thing, the interview questions. Okay. What is model analysis? Why we carry out the model analysis? So this question you should answer it properly. So in short, for the model analysis, why we do it? To extract the natural frequencies, that is resonant frequencies, and the normal mode shapes. Okay, so let's say if we have the mountain for the rotary machine, so we know that if you just place it, that particular mount cannot just withstand that particular loading condition. But when that particular machine, the rotating engine, starts rotating at a certain frequency, let's say 60 hertz or 3600 RPM. So with respect to that, there will be some vibrations in it, right? So whether that particular structure, the supporting structure, is going to withstand that loading conditions or not, that we need to cross check, right? So in short, this model analysis will help us to check the excitation. With respect to that excitation, a particular component is going under resonant frequency, or whether it is reaching it, or if it is reaching it, what exactly we need to do. Let's say the if it is rotating at 60 hertz, if entire board is if some components inside the entire assembly has 60 hertz, so we need to try to increase the or decrease the resonant frequency. Let's say 50 or more than 70 hertz, we need to try to keep it up like that. Okay, so again, in the model analysis, frequency analysis, why we take the first natural frequency only into account. So which one we need to consider? So they will throw the questions like hell. Okay, so let's say if you're carrying out the frequency analysis, which mode I need to consider, which natural frequency I need to consider, whether it is correct or not. They'll ask you the question. Definitely they will ask it. So try to take up more and more. If you don't know, refer my videos. Okay. This question very important. Explain about this UDM testing machine. So the interviewer knew that we all are the mechanical candidates. So every engineer, every mechanical student has used this universal testing machine. If we are 420 guys, we didn't attend this labs and all, we didn't know. You might not know about this thing, but very essential factor when it comes to CAE domain. So why we do it? What exactly the results you want to extract? So from that results, what we're gonna predict? Yep. So next question is the same thing. So from the UTM stressing machine, we're gonna just get the engineering stress and engineering strain values that we convert into true stress strain values. So why we need the true stress strain, right? So you need to explain why it is. Then again, the next question 5 was, if we know the engineering stress strain curve, why we need the true stress strain? Directly we can use this now. Why we need this? So one answer you need to add it there. Okay. So you already have this true engineering stress strain curve. So from this you're anyway calculating the true stress strain. So why we need the true stress strain? Just engineering stress strain is more than enough, no? Why we refer the industry standards true stress strain? So why we refer the laboratories and all? Why we extract the true stress strain curves and all in things, right? So there is a specific answer for that. Okay, try to just dig it up and answer for this. Very simple question but tricky. Get the answer for this. Okay, anyway, it is covered in my previous session. Please refer it. Next question, do you have any questions? So same thing. So this KPIT interview was quite interesting, but they have asked the very basic questions, very useful questions. Yep, so I hope this particular question session might help you to just go through these all the interview preparation process. Well, so that's all about this KPIT interview process, guys. In the next sessions, I'll be coming up with the few more industrial interviews and with answers as well. Well, that's all about this session. Thank you, guys. Stay tuned. Bye, everyone.